All right, so we're gonna dive right into it. We're presenting on finding solutions to downtown congestion, decades of multi-resolution modeling in review. So I think I last presented on this topic at UGM probably 2007. So this model's been around a while. So I'll go ahead and cover sort of the history of the multi-resolution modeling that we've done in Hillsborough, and then Kayla's gonna follow up with a recent example. So for those of you not familiar, Hillsborough is sort of the center of the Silicon Forest, just west of downtown Portland. It has significant regional through traffic, so there's some state highways that go through there and just limited connectivity to some of the communities to the west. So it has really high regional traffic, as well as being a town center with a lot of growth and employment, residential, and so it's kind of a destination outright in itself. So why we're using multi-resolution modeling here is we have a lot of different key objectives, and one of them is understanding that regional routing. Are we going to manage that into the future? This image off to the side is out of the regional or the city's transportation system plan, and that orange segment's calling for 7 lanes to accommodate the future growth, which mean wiping out circulation patterns. We want to evaluate intersection operations and really test different roadway configurations, everything from couplets, road diets, two-way lane conversions, and we'll go on a little more on that here in a minute. Some of the challenges we have from a modeling perspective are that grid network. So they're 200-foot block lengths. And if I go back to the image here, it's not just a through path. Everything's sort of converging into the town and going out one direction. So it makes it really easy to find a stair-step route through the town. And then we have a light rail line that frequently preempts traffic signals. So that causes spikes in queuing. So we've developed this multi-resolution modeling approach. We have a macro model. This is kind of a screen grab from the regional travel demand model. And then we've developed this meso sub-area model, which I'll talk about the details of that here in a second. And then we have a microsimulation model with vSim to get to those operational details. And so we have everything just sort of integrated there. So this is what in the top right up here, that's what the macro model looks like in downtown Hillsborough. It has the arterials, some of the collectors, very little local street connectivity, and just a handful of zones. So, right, that's pretty typical of what we see representing regional demand models. But we want to be able to look at this in much more detail. So we added every local street, so we have a full network there. And then we disaggregated the zones to have a block by block setup, and then connectors going pretty much to every driveway. And then really what's making this more of the meso, in addition to the detail, is we're using a more intelligent assignment procedure. So we're not going to a full DTA type assignment. We're using the intersection capacity analysis or ICA based assignment. So with ICA assignment, you're using the delay from the HCM calculation to come up with the impedance at each node. So we basically code every intersection to the full level that you would in a bistro or synchro model. So now when we change, say, intersection controls, turn lanes, that'll impact the assignment. And then so we could do our high level testing, diversion analysis, HCM analysis at that meso level, also develop our routing, and then export it to vSim for that detailed operations analysis, queuing, the rail preemption. And then let's see, we've used this for this one is actually from well, you can tell it's older because it's a picture of a newspaper, right? But we used this to do a kind of a 3D modeling workshop to help get the public kind of understanding what the tool is all about, get their acceptance, and then ultimately we got approval to do a street vacation. But we're still doing projects as Kayla's gonna show here in a minute. And just kind of a recap, downtown Hillsborough is one of the first vSim models in the country or in the US. And that was back in '98, hand built. model for the new light rail line that was going in at that time. So that was before my time. I first came in working with Hillsborough back when I was at PTV in 05. And that's where we developed the first model. You can kind of see we've just sort of built it up over the years. Each time we got an update here with the new regional demand model. We add more detail into the meso model. We initially started with Synchro to do the HCM, and then we brought it in to do the ICA-based assignment. Started off with a hand-built VSIM model, then kind of went to the A&M model, and we've really maintained that VSIM model now for about the past 12, 15 years, and just adjust it as needed. And this most recent one, you can see we also abandoned using DTA and VSIM. Calibrating DTA in such a small grid network was really challenging. And so we got rid of all that frustration, kept it the same, and really there's only a few routes. So when you get those Q spikes from rail preemption, there's a few routes that drivers are likely to take. So we basically did the dynamic routes, partial routes using the UDAs. And so that worked really well. And so we're currently working on a couplet, complete streets. And then, you know, I assume we're gonna keep maintaining this model, and I'd like to see about upgrading that to the Zoom SPA. So that's kind of the history of 20 plus years of modeling. And I'll let Kayla take it from here on the application.
So Randy got to chat a little bit about the methodology side of things. I get to talk about what I find most interesting, which is kind of the project application side of things. Maybe not talking to a room of PTV nerds who like the methodology side of things, but for our most recent project, again, downtown Hillsborough shown here on the screen, we've got some big generators that are all converging on this downtown area. In the orange here, you see OR8, which is a state highway that then turns the corner and becomes a couplet through the middle of the downtown area. And then 10th Street is the start of that couplet there. So that's the yellow that continues down to the orange. And there's really kind of a couple key drivers for this project. So Randy mentioned that the city's plan identified 10th Avenue there. It's 5-6 lane facility today as becoming a 7-8 lane facility in the future, which isn't something that the city or the community really desires, but it was identified from a congestion management standpoint. So we were trying to find alternatives to that 7 lane cross section or 8 lane cross section. And then we're also thinking about so that efficient and safe travel, but also kind of a re-envisioning of this area. So let me move to the next slide here. Here's a couple screen grabs from Street View. You can see the 5-6 lane kind of corridor. You've got pretty auto-centric development built right up against the right of way. So there's not a lot of room for expansion. So like Randy mentioned, going to that 7-8 lane corridor, you're going to be impacting a lot of businesses by doing that. And that's not something the city really desires. And you can see, well, you probably can't see, but there's some pretty narrow sidewalks in this area as well that are curb tight. Occasionally there's a bike lane on half of the street and it disappears midway through the roadway. So not an ideal environment from a multimodal perspective. And so when we were starting to look at the needs and opportunities for this area, one of our first findings was really that with the new forecasts, so Randy mentioned, we're kind of constantly updating based on updates to the regional travel demand model. With the newest model, we were able to show that the intersections on 10th Avenue could meet mobility standards in the future. So there's not necessarily that need for that big blowout project to expand the roadway as was identified with the previous model. But it is still near capacity and there are still some queuing challenges when you start to look at the 2040 conditions. So you can see kind of the circled in blue there is where that queue is starting to really extend back. And just for a little bit of context, just north of that, and maybe I can drag my mouse over here. The local hospital is right here too, so queuing is definitely kind of a concern in this area. And then one thing that was really important for the city of Hillsborough is that we're identifying a pretty big increase in emissions because of all this delay in queuing and congestion. And so impacting the people who live near the corridors. And then also from another standpoint, once you start to see these queues extend back this far, in practice, we could see more diversion onto some of the neighborhood streets. Again, because we do have a very grid-like structure here, so you can find alternate routes. A couple other needs. So this is a high crash corridor. I've got the crash heat map shown here on the side. I already mentioned the auto-centric land use and the gaps in the bike network. So this shows in street view, you can see bike lane on one side of the intersection, no bike lane on the other side of the intersection. So one of the kind of unique concepts that we tested, which Randy touched on briefly, is the idea of a couplet through this area. So you already have an existing couplet on Oak Street and Baseline, which are the east-west streets. We looked at what would happen if you turned 10th Street into a couplet with 9th Street nearby. So you can reduce the number of travel lanes on 10th Street because you would only need 2 to 3 lanes northbound instead of the 5 or 6 lanes that are there today. 9th Street is zoned for a more commercial land use, so you could kind of incentivize some development there by making it a more commercial friendly corridor. And again, this is kind of that alternate to widening to 7 lanes. The other big benefit with doing something like this is you really simplify your signal phasing at the convergence of these two couplets, right? Because you have that state highway turning the corner. Those two intersections are where you see a lot of the congestion spilling back from. So if you can simplify by removing those conflicts and spreading them out over multiple intersections, we thought that that might also address some of the queuing and congestion concerns. One other thing to mention is that with this, you do have to realign some of the local streets. So that's what's shown in green on the screen here, 9th and Main and also 9th and Cedar. And this shows in a little more detail what that kind of looks like on the southern end of the couplet. So where we bring these two roads back together to the 5-lane facility, you have a little bit of a realignment here with this intersection. You do have some property impacts, so that's something that'll need to be evaluated in a little more detail in a future phase of this work. But from an operations standpoint, that was the main thing that we were kind of evaluating and testing here. You'll also notice on the side, we started to see what the possibilities might be for all that extra space on 10th Avenue. So in this example, we're showing a cycle track on the right-hand side of 10th Avenue in green. And that gave us the opportunity to test what the impact of special phasing just for those bike movements might do on the signals and if we could accommodate that. So here again is that relative speed plot that I was showing before. We've got the no build on the left-hand side where you see that queue extending back for several blocks past the hospital. And then on the right-hand side, we've got that couplet model, which is showing that significant reduction in queuing and congestion for that approach in particular. Again, because we're simplifying the traffic signal phasing and we're reducing those conflicts. So again, I think I've mentioned a lot of these points, but I really want to hammer home that, this is a little bit of a unique idea and concept of really changing how people get in and out of downtown Hillsborough, but it does come with quite a few benefits. So you have reduced queuing, and with that, we were also showing reduced emissions in the modeling that we did. You have the ability to improve safety, you're reducing conflicts. We added a couple traffic signals, which can help kind of control speed and progression through the area as well. And then the big benefit here really is on 10th Avenue, that enhanced livability and placemaking opportunities. So on the screen here, you're seeing that reducing from that 5-6 lane cross section down to 2 or 3 lanes, you have a ton of space to work with now that the city can turn into a more friendly environment for all modes. And that's kind of an example of what you could do as shown here on the bottom. So if you had on-street parking, you could add a nice wide buffered bike lane, some street trees, really widen out the frontage for pedestrians, the sidewalk. You could have some space for outdoor dining as an example, right? So this is kind of really exciting from the city's perspective of what you can do with all that extra public space. And again, coming with that is that increased accessibility for all modes. And then there's a couple other projects that the city's looking at right now. And we were able to test the compatibility of this couplet concept with other concepts and other projects that the city is looking at, specifically on Oaken Baseline, where the existing couplet, where the couplet exists today. So I ran through that pretty quickly, but I'm going to pass it back to Randy for kind of wrapping us up here with some key modeling takeaways.
All right, thanks, Kayla. And one other thing to mention, because it's a lot of cities right now are going through the process of converting one-way streets back to two-way streets. And that's another one of the projects that we've looked at in downtown Hillsborough. And in their main street kind of core shopping district, they're doing that exact project to convert everything to two-way streets. But on these streets where we have all that regional through traffic that we just have to accommodate, there's not any roads to really bypass the downtown. This is where we could still make it a better place by going to the couplet concept to tie in those two directions. So overall takeaways kind of regarding the modeling and the process is it's efficient and more realistic for the demand development because we have all that detail in that meso sub-area model. And that the ICA based assignment provides a more realistic route than the MACO or the macro model. And it's a lot lower of effort on the calibration side than doing a DTA model. Would like to see the visualization aspect with the Zoom SBA. So again, something we're looking to the future with. And then supporting integration with the DTA tools. So I mentioned that we've previously used the DTA on the VSIM side. So that's something that we still have that hook in there if we want to be able to use that. And ultimately that meso to micro transition really saves a lot of time on the network development. And the big thing here is it's not a one and done. You could build these tool sets and, you know, here's proof right here that we've been using this sort of set of models for over 20 years. So they can be maintained effectively and cost efficiently. So for, you know, right now, one of these little projects comes up, it's not a big investment for the city to employ these models. So overall, cost-effective solution and something that you could have very confident results with. So thank you.